Hello, everyone. I'm audible. Perfect. Thank you. Okay, so today's session, it's about top mistakes to avoid in streaming applications. About myself, I'm Vikas Reddy, working as a staff backline engineer in Databricks from past 3.5 years onwards. So my area of expertise are streaming, Delta, and Spark SQL. So prior to joining Databricks, I was part of different consulting organizations where I used to develop big data applications. So totally, I'm having 12 years of industry experience. You can follow me in LinkedIn. So as per today's agenda, we'll be discussing common mistake scenarios. So, and apart from that, we will be recommending what are the best practices to come up with an optimized stream. Coming to the number one, so what could be issues when a user is neglecting the best practices while fetching the data from Kafka? Number two, so if user is choosing a wrong cluster configurations when there is a volatility in the data, what could be the issues? And if there are restarting the new stream, then if the user is not considering the significance of checkpoint, what could be the issues? Similarly, what are the problems with the trigger.once mode? So when there is an issue with the stream, what measures we have to consider? And when there is a stateful streaming operations, what are the optimization techniques we have to follow to optimize the stream? So when there is a stateful streaming restarts, if you're not considering the precautions, then what could be the problems? And finally, we'll be discussing about for each batch, the best practices to add as part of for each batch. So typically in any streaming applications, there will be multiple phases. So in the phase one, the stream data sources, where it will be generating the data. There will be some data generator, it will be generating the data. And that data will be ingested to certain kind of message queues. And there will be certain kind of processing engine which will be fetching the data from these message queues, and finally, the process data will goes to the destination. So in today's area, we'll be mostly focusing on stream processing engine while fetching the data from streaming, from data ingestion layers, or while writing the data to the destination. So what could be the mistakes at data ingestion layer? So how many of your streaming application fetches the Kafka, data from Kafka? Nice, that's a big number. Okay, so this scenario is about the Kafka. So user started the Kafka application trying to fetch the data from Kafka. Now, he passed all the essential configurations like bootstrap servers, and topic information for subscribing the topic, those things are covered. He is seeing a typical behavior in this Spark UI. So for each batch, there will be a stage, right? That stage, that particular stage focuses on fetching the data from Kafka. So when you look at that particular stage, all the batches of that stage where it fetches the data from Kafka, the same number of tasks are showing. Even though there are more number of cores, executor cores in the overall cluster, it is only showing the same number of cores across all the batches, that particular stage where it fetches the data from Kafka. Similar to this example where it's only like showing 8 as a particular task count while fetching the data from Kafka. So what is the problem with this? Why the entire cluster resources are not trying to fetch the data from Kafka? Only why few cores are utilizing while trying to fetch the data from Kafka. The problem here is with the default behavior, if there are n number of Kafka partitions, then only n number of tasks from our Spark it will be launching to fetch the data. For example, even though the overall executor cores are 12, let's take this example as 12. If Kafka partitions are only 3, then as part of that stage, it will be launching only 3 tasks to fetch the data from Kafka. So what is the recommendation here? How to utilize the entire computing capability while fetching the data from Kafka? So the recommendation here is min partitions. So if you think about Kafka performance, min partitions will play a very crucial role. So when to use this min partition? If there are more number of executor cores compared to the Kafka partitions, then we have to go with the min partitions. So what it will do? When we are passing more number of bigger value to this min partition, then this Kafka partitions will be virtually splitted into multiple smaller partitions. And when you launch this stage, the Kafka application, streaming application with this min partition, then whatever the number we came up with, equivalent to or rounded up to that particular value will be going with the number of tasks. So the number of tasks will be increased while fetching the data. If more number of tasks, more parallelism will be there, and it will improve the performance. The overall batch duration will be reduced. Okay, so now when to avoid this, this min partition? Let's say in one stream, in one application, if there are multiple streams, in that case, if you are passing more bigger count of cores value to the min partition, the problem is for few streams, there will be more cores that will lead to the uneven distribution of cores. So it's better to give an opportunity to framework itself to take a better value. Scenario 2. So let's say the user started a streaming application. It is trying to fetch the data from Kafka. But the Kafka topic is already there from some time onwards. So when you start a streaming application with at this moment, whatever the data is there from starting onwards in that Kafka topic will be fetched if you are using starting offset as earliest. Then it will be fetching lot of data. Huge data will be there in the source. So what is the problem with that? If there is a huge data, huge resources is required. And it will take more time. So resources is the biggest problem when there is a more data at the first batch. And from the second batch onwards, there won't be that much of data. This is one scenario. And other scenario can be, there will be off-peak and peak hours data. If there is a off-peak hour data, there will be less data. And if there is a peak hour data, there will be more data. If more data is there, more resources. If less data is there, less resources. Then let's say if user choosing a XYZ configuration. If that XYZ configuration, if is allocating less resources with respect to the peak data, then the problem is if it is a less resource, then peak data contains more data that will be occupying more memory while processing the data. So if more data is occupied in the memory, not having enough garbage collection is not properly done, then it leads to the long GC passes. And long GC passes, frequent full GCs, and finally it may lead to the out of memory issues or memory issues. So this is one scenario. And if the same user, let's say if he is giving over resources, excessive resources with respect to the peak hour data, off-peak hour data, then in off-peak hour data, less resources will be utilized. Less data, less resources. Then there is a chances for idle cores, which we are unnecessarily paying for that idle cores. So what is the right approach when there is a data volatility? Here the recommendation is rate limitation configurations. So when you want to go with a smaller cluster or limited cluster, which you don't want to spend so much of money on that particular cluster, then rate limitations will play a crucial role. So with respect to the Kafka source, there will be max offsets per trigger. When you give max offsets per trigger with certain value, then particular batch, every batch, based on that number, it will be fetching the data. So this rate limitations will be considered while fetching the data from metadata from the source. While fetching the metadata from the source, then there itself, this particular rate limitation will be considered. Let's say one example. If max offsets per trigger, I'm giving as a 10,000. But in my Kafka source, if there is 1 lakh records to fetch, while fetching the batch, even though if there are 1 lakh records, it will be fetching only 10,000 records. There is another example. If I'm giving a 10,000 as a max offset per trigger, but there is only 100 records per batch, 100 records in the source, then will it really wait for 10,000 records to accumulate in the source and fetch the data? No, it will not be waiting. It will be fetching whatever the data is there from the source. So it is just about, while calculating the metadata, if there is more number of records than the max offset per trigger, then it will be applicable. Otherwise, whatever the data is there at that point in time, that will be fetching the data. So if you're going with this approach, if there are n number of Kafka partitions, the ratio will be splitted across different partitions. So there won't be any uneven distribution while fetching the data. And moreover, the biggest advantage is controlling the resources. So even if you're having smaller resources, we can go with this rate limitations to come up with a proper data batch durations. And with respect to the delta, there's a max files per trigger and a max bytes per trigger. If you're using both as max bytes per trigger and max files per trigger, anyone will be used. Whichever is reaching the first, that will be considered. So now, if I'm using a trigger.1 scenario, in case of trigger.1s, whatever the data is there at that moment in the source, it will be fetched. For the second batch, it will be fetched based on the previous. Whatever the previous is there, from there it will be fetched. Everything will be fetched. Rate limitations will not be considered. So this is a caution we have to understand with respect to the rate limitation. Trigger.1s will not respect the rate limitations. Okay, so what is the role of checkpointing? Yeah, recover from failures, maintain the state. Any other answers? Process ones, exactly one semantics. Any other answers this side? Sorry, come again. Okay, but okay. Okay. Okay, yeah, it can. Okay, yeah, that metadata will be stored in that. Okay, at a high level, the checkpoint, the fault tolerance is based on the checkpoint. When there is a issues with the stream, let's say if the stream got terminated, when you restart the stream from where it needs to fetch the data, that information, that metadata is part of a checkpoint. Okay, let's go to next scenario. So based on the scenario, user decided, okay, there is a rate limitations. I want to fetch the data from Kafka, so I want to, my application is running currently. Let's stop the application, restart the application with a max offsets per trigger. And after executing that application, it was running for some time. When he observed the logs in the display metrics, he saw a typical behavior. For the first batch, it was showing that something different from whatever he given. For example, in this case, max offsets per trigger is given as a 5,000, but the number of input rows is showing as a 10,000. What is the problem with this? Why from the user point of view, why it is not respected the value which we given. So there can be two scenarios. One, while processing the data, he stopped that application, restart the application with a max offset per trigger, or while processing the data with some other max offset per trigger and restarted the stream with a new value, then it is not respected. Why? What is the problem? So here the problem is, by the time of termination, if the batch already fetched the metadata, right? So at a high level, what will happen? At the time of, while restarting, if the metadata is already fetched as part of previous batch, then the problem is it will be fetching the same data based on the metadata. Let's elaborate this. Let's understand the checkpoint internals while restarting a stream. So when you look at this, there is a checkpoint path. Under that checkpoint path, there is a couple of files with respect to offset folder and with respect to commits folder inside the checkpoint. So when you restart the application, framework will list out all the files with respect to offset folder and picking the latest file. Similarly, it will be listing the all commit files and picking the latest commit file. Now, it will be comparing both the files, latest offset file and latest commit file. If latest offset file is greater than latest commit file. So in this example, the latest offset file is 4 and latest commit file is 3. So 4 is greater than 3. If 4 is greater than 3, then from framework point of view, while processing the previous batch, it got terminated. So I have to resume from batch ID 4 onwards. So batch ID 4 was processing previously, and it got terminated without writing the data or writing to the checkpoint, committing to the checkpoint. So that's why I need to resume from batch ID 4 onwards. So in that case, metadata will only fetched from the latest offset file. The max offsets per trigger will not be considered. And let's take the other scenario. If framework is comparing the both latest offset file and latest commit file, if both are same, then what is the thing? So from framework point of view, while processing the previous batch, it got properly processed, commit to the return to the destination, and committed information to the checkpoint. So in that case, when you restart the stream, it goes to the source and fetch the metadata. While getting that metadata, the rate limitation will be considered. So here the point is, the checkpoint plays a major role when there is a restart. So let's look at the Kafka logs. So from this information, we can get it from driver logs. So it will be listing as offset. In the offset folder, it is listing 0 to 4, and picking the latest offset as 4. And similarly, for commits folder, it is listing 0 to 3 and picking the latest commit as 3. And it is telling in the next line that the last started batch is 4, but only 3 is committed. So I have to resume it from batch ID 4 onwards. That's what's happening when there is a mismatch with the latest offset and latest commit. So what we have to do? If you are very particular about when you start the application, whatever the rate limitation we given, it should be applicable in the first batch itself, then we have to be a little cautious on this checkpoint, offset folder, and commits folder. So we have to compare both latest offset and latest commit. If there is any mismatch, if offset folder is greater than latest commit commit file, then we have to delete the latest offset file. So be cautious while you're doing it in production. Please take a backup. Otherwise, there will be negative consequences with this. Okay, scenario number 4. So why do we go with a trigger.once? So in case of trigger.once, let's say I don't have any strict SLAs to write the data to the destination. If the producer team is not producing the data constantly to the source, then there is no point of keep on running the resources continuously just like that. So that, I mean, if you can stop for certain duration and restart after certain duration, fetch all the data and again stop it, then again restart after X interval, that will give an advantage with respect to the resources cost. So that's how we will go with trigger.once mode. That's a reason for that. Now, when there is a volatility in the data, so what will happen? With respect to the trigger.once, rate limitations is not considered. So when there is a volatility, how to choose the right cluster configuration? That's a little difficult, right? If volatility is only little, that's okay. If there is too much of volatility, then it's really big problem. So again, the issues is if you're giving more resources with respect to peak hours, then it may lead to the memory issues. If you're giving, if you're going giving less resources with respect to the peak hours, then it requires more memory while processing the data, and that leads to the full GC, garbage collection, and long GC passes, frequent full GCs leads to the out of memory. Otherwise, if you're giving more resources with respect to the off-peak hours, then it requires less data, it requires less resources. We are ending up paying unnecessary resource costs for idle cores. So what is the right approach? Okay, so how many of you guys are using trigger.once here? Exactly, that's a point here. So here the point is trigger.available now is a latest improvised feature. So when you're going with trigger.available now, so it will be doing the same kind of feature whatever is going with trigger.once, but it will be processing the data in multiple batches. It will process all the data, but it will be processing in multiple batches. How it is processing multiple batches? Because it is respecting the rate limitations. So as we discussed, for different sources, there are different rate limitations, max offsets per trigger for Kafka, max bytes per trigger, max files per trigger for Delta. So this is available from Spark 3.3.0 onwards. So after encountering an error, did you restart a stream with a new checkpoint and you saw, okay, issue got mitigated, now stream is fetching the data? Have you guys encountered this kind of issue? Okay, one hand. Yeah, so now user restarted a stream and suddenly there was some issue with the XYZ and application got terminated. What is the problem with this? And not only that, I mean, when you restart the application with a new checkpoint, what will the problem? Let's take an example with respect to the Kafka. So user is trying to fetch the data for Kafka with starting offset as earliest. So the previous application was processed for a long time, and suddenly, due to some issue, he wiped out the checkpoint and restarted the application with a new checkpoint, and that too, while reading, there is a starting offset as earliest. Then what will happen? It will be fetching all the data from starting onwards. That will be a killer with respect to the resources and with respect to the data. It will be reprocessing the same data again. And for reprocessing the same data which was processed earlier, this will unnecessarily using the resources. What will happen if it is reprocessing the same data? It will be ending up writing the data to the destination. That leads to the duplicates. So how to efficiently handle this scenario? So first of all, we have to identify what is the root cause and find out the solution for the root cause. If you're not identifying the root cause, then the problem is even after restarting the application, at the same point in time, wherever the previous stream got terminated, even in this stream also, the possibility to terminate. So first recommendation is we have to understand the issue, root cause, and finally come up with a mitigation. Let's say that's not the case. Then there are other options for different streams. From where it got processed as part of previous batch, we have to understand with respect to the checkpoint. And finally, based on that information, we can fetch the data from where it got left. So with respect to Kafka, we can go with starting offset, and we can pass the topic information, partitions information, and to specific information where it got left. As part of the latest offset and latest commit information, from there we can understand till where it got committed, and based on the latest commit equivalent to the latest offset, get the end offset as the starting offset for your new stream. So that's how you can avoid the reprocessing of same data. And second one is no need to use unnecessary resources. So let's say even that is not the option. So the only last option is deleting the checkpoint. But consider two important points. If you going with restarting a checkpoint, restarting a stream with a new checkpoint, whether your streaming application considering the duplicates, is it handling efficiently? If it is not, then whether the destination sync is handling efficiently, either we have to understand this. If both are happening, either one of these happening, then we can go with it. Otherwise, that's not recommended. Let's discuss about the mistakes at data processing stage. How many of your streaming applications are using stateful operations? Okay, that's a good number. Okay, so what is a state? So for example, if I'm going with a drop duplicates, for each and every batch, it will be collecting some unique keys. So that unique keys should be stored somewhere. And the collected keys will be used for comparing for the next set of batches. So finally, we'll be keep on collecting the data. If you keep on collecting the data, there should be somewhere to manage this state and something to handle this efficiently as a state store. So now let's say if they keep on collecting the data and it is not, there is no call termination for that because this is 24/7. Every time it is running, keep on running. So what is the problem with this? Over a period of time, this data will be accumulated, correct, in somewhere. That somewhere is called memory with respect to the executor JVM. So if more memory is utilized, then over a period of time, it leads to the performance issues because of the occupation of more memory and because of full GCs, frequent full GCs. This is affecting the batch duration. So what we have to do? What is the problem behind this? So it is not limiting the state store. What is the recommendation for this? Watermark. If you're going with the watermark, the outdated data will be wiped out. So this is also helpful for the late arrival data. So till where that late arrival data can be considered as part of the state. So by doing this, this is a periodic cleaning. For every batch, it will be recalculated. So based on every batch, the unnecessary data will be discarded. So over a period of time, if the state is constant across multiple batches, then no need to go with the bigger resources. With the same set of resources, we can efficiently manage this batch processing. And we can expect the similar kind of batch duration across multiple batches. Scenario 7. So let's say, with respect to the stateful operations, if user needs to store millions of keys Even though after applying this watermarking, still he needs to show millions of keys. Then if millions of keys are using, and if it is unpredictable where data volatility, a lot of things comes into the play, then what will happen? Again, this needs to be stored somewhere that requires memory. So by default, the problem with this is we are using the HDFS state store. The HDFS state store using the executor JVM memory. If it is using the executor JVM memory, if more keys is part of the state store JVM memory, that will be impacting the performance over a period of time. So what is the approach? RocksDB. RocksDB is a solution for this. With the same set of resources, we can go with RocksDB. The RocksDB leverages the local SSD disks and native memory to handle this state store information. So whatever it is doing like a state store, the same, even in RocksDB, whatever the data is updated as part of every batch, after completion of every batch, that information, state information goes to the state store as part of checkpoint folder. So with respect to the OSS and Databricks, these are the configuration we have to enable to go with a RocksDB. So here the caution point is, when the application is running, and if user is decided to move to another state store, either RocksDB to HDFS or HDFS to RocksDB, we need to restart a new application with a new checkpoint. Scenario 8. So user decided to change the spark.sql.shuffle partitions, right? This is with respect to the stateful operation. Then he restarted the application. He's looking at the Spark UI, but he didn't see any changes with respect to the number of tasks for shuffle operation. It's the same number of tasks it is showing. What is the problem with this? Why it is not respecting the value, new value which was given? The reason here is the new value will not be considered at all. Because let's take this example. In this example, it is showing the shuffle partitions as 200. And in the RocksDB, this is a checkpoint. Under checkpoint, there is a 0. For each stateful operation, there will be one subfolder. Under that subfolder, there will be another subfolders. Here it is showing as 190 to 199, 194 to 199, right? So that value is equivalent to the number of shuffle partitions. If there are n number of shuffle partitions when you starting your stream as a fresh stateful operation, the same number of subfolders will be created as part of each and every stateful operation checkpoint folder. So if that number is changing, that will be corrupting the state store. To avoid that state store corruption, framework is not accepting the new values when you're restarting the application. So here the recommendation is, we have to understand what things are allowed, what are not allowed while restarting a stateful streaming application. Let's discuss about the mistakes at data writing stage. Let's take this scenario. The user started a streaming application. It is trying to fetch the data from Kafka. So it is running, and suddenly when he saw the display metrics in the logs, it is showing that starting offset for my Kafka topic, the 0 partition, it is starting from 0, but end offset, it is showing as 0 to 50, 0 partition as 50. So it means 50 records got processed. It's always -1 at the end, 50 -1. So 0 to 49 records got processed. But why the num input rows are showing as 100? That's a problem. There is a mismatch in the number, what it is displaying, and what it is really processed. What is the problem here? Here the problem is, customer is using the for each batch, and inside the for each batch, there are multiple actions. If multiple actions as there, then there is a chances for rereading of input data from the source. this will impact the performance, and similarly, it will be unnecessary using the resources. And moreover, it will create the confusion in the metrics, display metrics. So how to avoid this? So we have to cache the data before executing the multiple actions in the for each batch. And finally, we have to unpersist it so that it will be cleaning all the cache data for after completion of each batch. Let's discuss about the key takeaways. So remember one thing, if you want to boost your Kafka performance, think about min partitions. And if there is a volatility in the data, consider the rate limit configurations, max offsets per trigger, or max bytes per trigger, or max files per trigger. These are the rate limit configurations. When you're restarting a query with a rate limit configurations, you have to understand what is a latest Kafka, latest offset with a commit, latest commit. So number 4, trigger.available now is a latest improvised to trigger.once. So this will be respecting all the rate limitations while fetching the data so that it can efficiently handle even when there is a data volatility. Number 5, when there is an error, we have to understand what is the issue and come up with a mitigation for that issue, rather than just restarting the application with a new checkpoint. Number 6, when you're considering the stateful streaming operations, we have to go with a RocksDB as one optimization, and watermark is another optimization, so that even with limited resources, we can efficiently utilize the capabilities. Number 7, when there are stateful streaming operations needs to be restart with certain number of changes, we have to understand, first of all, what changes are allowed and what changes are not allowed. The reason for this is not to corrupt the state store data. Number 8, when you're going with a for each batch with multiple actions, then consider going with pre-caching the data frame before calling the multiple actions. And my famous quote, I love this quote actually, prevention is better than cure. In the world of technology, it's better to prevent ahead than fix them later. Thank you.